Welcome to Module 4, the root cause. We will explore how low growth acts as the primary driver of persistent reading underperformance, moving from initial diagnosis to policy prescription. In this module, you will learn to articulate the central theoretical claim of the Hare framework and explain how this theory inverts conventional crisis framing. We will also evaluate the empirical proof using Albuquerque data and propose minimum growth standards as a primary policy intervention. The central theoretical claim is that the root cause of persistent reading underperformance is not the size of the initial gap, but rather the failure to generate sufficient growth to close it. Conventional framing focuses on the gap. Policy discourse targets the distance between where students are and where they need to be. Interventions use remediation and catch-up programs, assuming that addressing the gap directly will lead to student catch-up. The Hare inversion shifts the focus to the growth rate. The growth rate is the policy lever that districts can control and determines the timeline to proficiency. Under this framework, the gap is the symptom, not the cause. To summarize the core difference, the gap is the symptom, and insufficient growth is the disease. Conventional approaches treat the symptom, while Hare advocates treating the disease, the growth rate. This distinction matters for policy. Gap-focused policy uses remediation, tutoring, and extra support services, which only treat symptoms. Growth-focused policy implements minimum growth standards, system accountability, and trajectory monitoring to address the root cause. Let's dive into the Hare threshold. The threshold is 0.025 sigma per NAEP cycle. This is the floor below which recovery becomes mathematically impossible within any human timeframe, often converting timelines into centuries or millennia. The 0.025 sigma rate is categorically different. It is 1/10 of the US norm and only about 7% of the 25th percentile baseline. Only active retreat or severe stagnation can produce growth this low, meaning it is categorically insufficient. The times 10 proxy is a mathematical consequence, not a penalty. When the effect size is less than 0.025 sigma, the system is actively widening the gap. The proxy captures the compound damage that linear extrapolation cannot, as negative growth worsens the status quo every cycle. This table visualizes compound damage. At a baseline gap of 27.84 sigma, a consistent negative growth of minus 0.71 sigma per cycle accelerates the problem. By cycle 7, the cumulative gap has grown significantly, showing the compounding nature of the problem. A district with minus 0.71 sigma growth is actively increasing the achievement gap by 0.71 sigma every 2 years. After 7 cycles, the gap has grown by almost 5 sigma. This represents measurable, sustained retreat, not mere stagnation. Consider the English learner exception in Albuquerque. English learners showed positive growth of plus 0.12 sigma with a proficiency timeline of 25 years. However, all students had a negative growth of minus 0.71 sigma, resulting in a timeline of 1,120 years under the Hare proxy. This data proves the Hare theory. For English learners, positive growth translates to a normative timeline. For all students, negative growth leads to an infeasible timeline. This comparison proves the theory in a single data set. The district, assessment, and target are all the same in this comparison. Only the growth rate differs. This demonstrates that the direction of growth is the sole determining factor in closing the achievement gap. Next, we will cover the 5-step empirical proof, which uses data to demonstrate that low growth is the root cause of the achievement gap. The steps are observed fact, logical consequence, mathematical proof, counterfactual proof, and cross-subgroup proof. Proof step 1 is the observed fact. Albuquerque grade 4 reading has an effect size of minus 0.71 sigma over the 2009 to 2024 study period. This is calculated directly from NAEP tutor data and is not an estimate or projection. Proof step 2 is the logical consequence. Negative growth does not maintain the current gap. It actively increases it. Every 2-year NAEP cycle at minus 0.71 sigma makes the gap larger, moving the system further from the goal. Proof. Step 3 is the mathematical proof. The gap to proficiency, G2P, is 27.84 sigma. The Hare proxy yields 1,120 school years for recovery. However, at the actual negative growth rate, the timeline is mathematically infinite because the gap is expanding. Proof step 4 is the counterfactual proof. Under any positive growth scenario, the impossible timeline collapses to define targets. This confirms that the variable that truly changes the outcome is the growth rate, not the gap size, demographics, or funding. Proof step 5 is the cross-subgroup proof. English learners achieved positive growth of plus 0.12 sigma, eliminating the proxy and resulting in a 25-year timeline. This subgroup demonstrates that positive growth, not the initial gap, determines the time to proficiency. In summary, the 5 steps confirm that an observed fact of minus 0.71 sigma leads to the logical consequence of gap expansion. The mathematical proof shows an infinite timeline, which counterfactual models prove can be collapsed by positive growth, as demonstrated by the cross-subgroup proof. Insufficient growth is the root cause. We now transition from diagnosis to prescription. Since insufficient growth is the root cause, the next question is, what policy intervention addresses this specific problem? The single most powerful intervention is establishing a minimum growth standard. This is not an aspirational target, but a legally binding, data-monitored floor linked to consequences for failure. A target is an aspirational goal with no consequences for failure, often ignored. A floor, however, is a minimum legal requirement with consequences, and the Hare framework argues for these enforceable floors. A growth standard of 0.25 sigma would have yielded a 2024 score of 202.98 compared to the actual score of 201. This small difference of 1.98 points, however, reduces the timeline from 1,120 years to 112 years, a factor of 10. A minimum growth standard, even at the lowest normative level, reduces the timeline by a factor of 10. This converts an impossibility into a multi-generational challenge, a significant difference that matters immensely for students. The 1.0 sigma standard is an ambitious goal that would reduce the timeline to proficiency to 28 years, or about 4 times the national norm. This rate is aggressive but achievable, given the high effect sizes seen in effective reading interventions. Evidence supports the 1.0 sigma standard. Direct instruction programs regularly produce effect sizes between 0.5 and 1.5 sigma. Structured literacy at scale also achieves accelerated growth. This level of growth is possible with the right programs and accountability. A 1.0 sigma growth rate achieves proficiency in 28 years, which is within the career span of a teacher hired today. This is not theoretical fantasy. It is mathematical certainty when growth is prioritized. The 2.0 sigma standard is the transformative goal, reducing the timeline to proficiency to just 14 years. This is 8 times the national norm and achievable within a single mayoral or gubernatorial term of office, requiring rigorous accountability. This slide sets up the comparison of various policy scenarios concerning growth standards and the resultant consequences based on the Hare model and NAEP TUDA 2024 data. At the status quo and the lowest floor standards, the timeline remains 1,120 years, representing an impossibility. Achieving the national norm reduces the timeline to 112 years, still a multi-generational challenge. Accelerated growth at 1.0 sigma puts proficiency within 28 years, a single generation. Transformative growth at 2.0 sigma shortens this to 14 years within a typical career. Both are achievable with political will and evidence-based programs. The human meaning of these standards is profound. Status quo means geological time, while the national norm affects great-grandchildren. The 1.0 sigma rate impacts children, and the 2.0 sigma rate achieves results within current teachers' careers. Each scenario requires a different level of policy intervention and commitment. The data confirms the need for transformative change to achieve meaningful results quickly for students today. The Hare framework is not specific to New Mexico. It applies to Michigan and any other state or district with similar patterns of negative growth. The mathematical consequences are universal. Any entity with growth below 0.025 sigma faces the same impossible timeline. The math and policy prescription of minimum growth floors are universally applicable across different assessment datasets like NAEP or NWEA map. To summarize Module 4, insufficient growth is the root cause. This is proven by observed data. Minimum growth floors are the policy solution. Achieving 1.0 sigma growth puts proficiency within a single generation. Here are some review questions for Module 4. Consider how the Hare theory inverts conventional framing, the difference between a target and a floor, and what growth rate ensures proficiency within one generation.